Picture this. You pour the perfect steaming cup of coffee. You set it down, get like totally distracted by an email, and 20 minutes later, it's just tragically lukewarm.
Oh, yeah, it is the absolute worst feeling. And what if I told you the exact same invisible force that ruined your morning brew is also guaranteed to eventually destroy the entire universe?
Right. Welcome to today's deep dive. Our mission is to explore entropy, the inescapable rule book that governs everything from your daily routine to the ultimate fate of the cosmos.
It really operates entirely behind the scenes of our lives. It dictates how energy moves, why things break, and basically why the universe behaves the way it does.
Okay, let's unpack this. Think about that hot cup of coffee. When it's freshly poured, all that thermal energy is concentrated, right? It's highly organized, which in physics is a state of low entropy.
Exactly. But as it sits there, the heat just kind of disperses. And I mean, this isn't just magic, it's physical. The incredibly fast, hot molecules in your coffee are literally bumping into the slower, cooler molecules in the air.
They're transferring their momentum, basically.
That's right. They keep crashing into each other until everything in the room is moving at the exact same average lukewarm speed. The energy spreads out, gets totally disorganized, and becomes wasted. That is high entropy.
Got it. And the Austrian physicist Ludwig Boltzmann was the first to realize that this spreading out of energy is really just a simple game of statistical probability, wasn't he?
He was, yeah. Back in the late 19th century, he figured out that we shouldn't just look at the overall temperature of the coffee. The big picture, which he called the macro state. The secret actually lies in the microstates.
Wait, hold on. Microstates. Are we talking about the microscopic chaos here, like the exact coordinates and speed of every single jittery atom in that mug?
That is actually the perfect way to visualize it. Boltzmann showed that entropy is basically a measure of how many different microscopic atomic arrangements can produce the exact same big picture macro state.
Okay, let me pause to process that. If entropy is just probability, based on how many ways things can be arranged, does that mean my chronically messy bedroom isn't a character flaw? Is it literally just the fundamental laws of physics playing out?
Well, what's fascinating here is mathematically speaking, you are completely off the hook.
Oh, thank goodness. I am definitely using that excuse.
I mean, think about a perfectly clean room. There are vanishingly few ways for every single object to be exactly in its designated spot. That highly organized state is low entropy, and statistically, well, it's incredibly rare.
But a messy room. There are millions of different ways your clothes and books can be scattered across the floor.
Okay.
And they all result in the exact same big picture of a total mess.
Exactly. Because there are, so overwhelmingly many chaotic configurations, the messy state is highly probable. This is really the heart of the second law of thermodynamics. Isolated systems naturally evolve toward maximum chaos simply because there are vastly more ways to be messy than to be neat.
So probability dictates my room gets messy over time. But wait, I can easily spend 20 minutes and clean my room. Why can't I clean up or reverse other messy things like a shattered egg?
Because cleaning your room requires an input of outside energy, like your physical labor. Without that external effort, natural law dictates things just fall apart. Think about an ice cube melting into a puddle.
Right. Once the rigid grid-like structure of the ice breaks apart, those water molecules just move randomly. You can't unmelt that puddle back into a perfect cube without applying external energy from a freezer.
Exactly. That one-way street from order to disorder feels super profound, and it gives us what physicists call time's arrow.
Time's arrow. That's the reason we can distinguish the past from the future, right?
Yes, the reason you can vividly remember drinking that hot coffee, but you can't remember tomorrow, is entirely because of how those atoms are constantly spreading out. The past always has lower entropy than the future.
So it's less like the universe is a ticking wind-up clock running out of juice, and maybe more like a single drop of food coloring in a glass of water. Eventually, the color just dilutes and spreads until everything is an inescapable uniform gray.
If we connect this to the bigger picture, that uniform gray is exactly where we are headed. Astrophysicists project that over trillions of years, the total entropy of our isolated universe will just keep increasing.
Wow, so all thermal energy will eventually be completely evenly dispersed across all of space?
Exactly, which means no heat can flow, no stars can undergo nuclear fusion.
And no complex matter or life can exist. The universe will just reach this absolute lukewarm equilibrium point.
Right. This ultimate state of maximum chaos is known as the heat death of the universe, or the big freeze.
Man, it's both terrifying and strangely poetic. Entropy is this beautifully tragic reason why things break, why time pushes us relentlessly forward, and why that coffee refuses to stay hot.
It really is the ultimate inescapable rulebook.
So what does this all mean for you listening today? Well, it leaves us with quite the mind bender. If our universe is a closed system that is constantly, irreversibly moving from a state of order into a state of total disorder, it must have started in an incredibly rare, perfectly ordered state.
Which is a huge cosmic mystery.
Exactly. So, as you go about your day, ponder this. What or who cleaned the room and organized all that concentrated energy in the very beginning? Something to think about while you enjoy your coffee, before the universe turns it lukewarm.